friends, this is Kajal Ramfri from KG College, Kamartha, and I'm pursuing my BSc second semester from here. After students got their topic for the presentation, among this, I got my topic that is the application of viscosity, which is guided by Dr. Dipti ma'am, Mr. Sanjay Yadav sir, Mr. Santosh Kumar Jaharia sir. Once William Atherwald said, the mediocre teacher tells, the good teacher explains, the superior teacher demonstrates, and the great teacher inspires. And truly, because of their constant encouragement, support, and guidance, we all students are moving forward. It's just because of them. This assignment is not just about understanding the scientific concept, but also boost our confidence, improve our communication skills, and more importantly, that how to express our point of view in front of others. It truly enhances our personality. Before going ahead, I want to ask one question to you. Have you ever paused to wonder why the honey graceful in its slowness, why the water rushes is in its stillness, and how the engine or silently safeguards our machines from damage, and how the blood travels through thousands of veins for sustaining every heartbeat of life. Do you think that? What will the answer? The answer relies in a remarkable and unnoticed property of fluid. That is viscosity. Viscosity, it is the hidden force that controls the flow, creates the balance, and brings efficiency countless for many of the systems around us. From food we enjoy to the vehicles we drive, from the life-saving medicines to a giant industries, viscosity plays an extraordinary role in shaping our modern world.
That's a fancy science word for how thick or thin a liquid is. Let's shrink down. Inside water, the tiny molecules are smooth and don't hold on to each other very much. They can slide past each other super easily. This creates a thin, fast-flowing liquid. This is low viscosity. But inside honey, the molecules are bigger and stickier. They love to grab onto each other and don't want to let go. This creates a lot of friction inside the liquid, making it thick and slow-moving. This is high viscosity. We can test this. A marble sinks fast in low viscosity water, but super slow in high viscosity honey.
I hope you should watch that video which I should show to you. So you see on that video why the honey is so viscous as compared to water. Let me explain you in a simple term. Because if you see the particles or the molecules of honey is very large as compared to the particles present in water. And the second reason behind is that due to the strong intermolecular force present within the particles of honey is stronger as compared to the water. That's why honey is so viscous as compared to water. Today I got the topic about the application of viscosity. So let me explain you. Before going ahead, I want to tell you what is the viscosity exactly it is. Let me tell you the technical definition of viscosity. Viscosity, it is the property of fluid which registers its flow or internal friction between its layers when it moves. Let me explain. When you hear the word fluid, you just start imagining that something that is liquid, but you're wrong. Fluid means the substance which can easily move. It includes liquids or gas. Now let me explain the second line, the internal friction between its layer when it moves. It means suppose this my both hands are the two layers. This one is the first layer and this one is the second layer. This second layer does not want that this first layer move, so it will create the opposition so that this first layer does not move. That is the internal friction between its layer when it moves. I hope you already have seen the pounds. If you see the top layer of that pound, it moves very smoothly as compared to the bottom layer of that pound. Because of mud, it becomes so viscous as compared to the first layer. So that's the why. If you see from the top layer to the bottom layer, the speed, the velocity decreases. So you can see here how the velocity decreases from the top to the bottom. Now let us see the application of viscosity. The first application of viscosity we see, that is the food industry. This one. So viscosity determines the texture and the flow of the product. For example, ketchups, chocolate syrups, so that it helps in a proper packaging, pouring and maintaining the good quality of that product. Now let us see the next application of viscosity in cosmetic. I know you, whenever you hear this word, you just start amazing. The girl. You are wrong. Boys and girls both use it. So viscosity plays a crucial role in the cosmetics because for the easy application of that. Now let us see the products like shampoos or toothpaste. So it have the proper viscosity for their thickness or the smoothness for the easy application. Now the next application of viscosity that we see in paints and paintings. So what happens if the paint is so thin, then you have to, it will spread throughout the wall easily, but you have to coat multiple times. For multi-coating is required if the paint is so thin. So smooth or proper viscosity of the paint is essential for the easily smooth spreading of this throughout the wall. If it is so thick, then if you will see it will stuck at a particular place and you will see the brush markers on that place. So proper viscosity is very important in printing as well, so that for the proper sharp, neat and clean printing. Let me explain what happens if the paint is so thin or thick. Let me draw. Here is the end. If the paint is so thin, then it will like a runny. You have to apply the paint multiple times. If it is so thick, then what happens? It is stick at a particular place and you will see the brush marker on that place. Now let us see the next application of it in industries and machines. So manufacturers use liquids in pipelines and machines, so the proper knowledge of viscosity helps them in a smooth operations and it saves the energy. If you see the next application of viscosity in transportation and automobiles, then viscosity plays a crucial role in engine oils and lubricants, so that if it is proper viscous, then it will reduce the friction. So between the parts of the machines, it will prevent overheating and increase the life of engine. So viscosity plays a crucial role in these industries and automobiles transportations. Now let us see the next application. Before going ahead, let me tell you what happens if the engine oil is so thick or thin. If it is so thin, then this liquid fails to create a boundary layer leading to a friction and physical wear. If it is moderate, then it will smooth, easily work. If it is so thick, then the machine expends the excess energy just to overcome the internal friction of that liquid itself. Now let us see the next application of this, that is we see in blood. So as you all know that blood is very important for all of us. You know, blood is a fluid and it is a connective tissue. So proper viscosity or viscous of the blood has an smooth circulation throughout our body. If it is so thick and thin, it will adversely affect and cause several health problems. If we see the viscosity in liquid medicine, then it plays a very crucial role for it. For liquid medicines are strictly formulated with suitable viscosity for easy use and absorption within the body. For injection, if you see syrups. So what are the diseases which are caused by, affected by, if the viscosity is not proper? If it is so thin, then you have here the disease name, that is anemia. So low concentration of RBC reduce overall blood viscosity, alternating normal circulatory resistance. If it is so thick, then you can see here the hypertension, thick blood increases systemically and resist, leading to elevated the blood pressure. Then stroke and the heart attacks. High viscosity encourage cord formations which can block the vital arteries to the brain or heart, that leads to the stroke or heart attack. Do you know that how beautifully the God has created this world? And viscosity affects the flow of a river and the lava from the volcanoes and even also air movement in atmosphere. Here is the examples you can see here. So because of the proper knowledge of viscosity, scientists trust viscosity to understand the mass natural processes and elemental flow in construction work. Then I can say that it is the milestone for it, because engineer relies on a specific fluid resistance for easy mixing, metal spreading and establishing strong binding in infrastructure. For example, formulating the perfect cement paste, pouring concrete slurry and applying heavy duty glues. You can see here how this works is done. At last, let me tell you the universal flow spectrum. So in this, it shows which substance has a low viscosity and which one has a high viscosity, from low to high. Here you can see the air has a low viscosity, then water, then middle zone you can see that is the blood and printing ink. After that you will see the car or engine oils or shampoos. That high viscosity zone, that is the honey, chocolate, ketchups, and extreme viscosity you will see the lava and the cement. At conclusion, I can say that viscosity is invisible but a powerful property of fluid. It supports health, transport, life-saving medicine, interests. Without it, many of the system fails to work properly. Last but not the least, at the last, you can say that truly viscosity is silentary controller of movement and progress. Thank you all for your patience and have a nice day to all of you.